Hello, everyone. I wanted to make you a couple of quick videos for exponential functions. So, sorry about that. For exponential functions to help with homework 12. So let's start with what an exponential function is. It's basically a function that has the form y equals a times b to the x power. That's what an exponential function looks like. And basically a, which is a coefficient, it can be any number it wants except 0. And that's because if we were multiplying by 0 here, it would push the whole thing to be 0. That wouldn't be an exponential function anymore. That would be y equals 0. B is called the base of our exponential function, and it can be any positive real number except 1. So the base of this exponential right here, it can be any positive number. We can't let it go negative because a negative number, if you raise it to different powers, it jumps between positive and negative values, and it just acts very strange. So we're going to keep our base positive so that we have positive numbers to powers, and those will all act pretty much the same way. We're also not going to let our base be equal to 1. And that's because if you have 1 to any power, it's just 1. And again, it's not going to act like a normal exponential function. So your base b can be any positive real number except for 1. And x is your variable. And x must be in your exponent in order to be an exponential function. That's what makes an exponential function exponential. The variable is in the exponent. All right, one last thing before we kind of get into this. E, the value of e. We don't use the letter e for variables. This is a very specific number. Just like pi is a very specific irrational number, right? It's 3.14159 ... continuing on forever. E is also a very specific number. It's an irrational number, so that means non-terminating, non-repeating decimal. E is approximately 2.71828 ... Again, it goes on forever, but E is approximately 2.7-ish. It's a lot like pi, just with a different number. And anytime that we use an E, it's not a variable. It is this number, 2.7-ish. We call it E. Sometimes it's called the natural number, and sometimes it's called Euler's number. It's named the letter E after Euler, who is the guy that published this number originally. So he's given credit for kind of discovering and publishing this number, and so we named it E after him. All right, so E is a very specific number. This is what an exponential function looks like. A couple things that we're going to be doing with this. One is a word problem, and the other is graphing. So let's start with this word problem. So a can of soda is placed inside a cooler. As the soda cools, its temperature, T of x, in degrees Celsius, is given by the following function, where x is the number of minutes since the can was placed in the cooler. So here's our function T of x. Find the initial temperature of the soda and its temperature after 15 minutes. Okay, so this is our function. Let's see, let's try to make some sense of this. X is my variable that's going in here, right? That's my input variable. And what is X? What am I putting in? All right, X is time in minutes. So X is the number of minutes since we put it in the cooler. And then what comes out? So I'm going to make note of that. So we put minutes in. And what comes out of this thing? T of X. When I put in the minutes after it was in the cooler, what comes out? T of X, this is degrees Celsius. So we get degrees Celsius out. So we put time in, we get temperature out. All right, and that's what we look like. Okay, we are asked to first find the initial temperature of the soda. All right, initial temperature. That means the temperature at the start of this whole thing. So if I want to know what the initial temperature is, I want to know what's the temperature when the can was placed in the cooler, right, initially. That means that our time, x, is 0 minutes. So I'm going to go ahead and plug x equals 0 in. We'll get the temperature out, and that's going to be our initial temperature. So our temperature is going to be -7 plus 27 times e to the negative 0.04 times 0. All right, and we got to figure out what our initial temperature is. So we're going to have -7 plus 27 times e to the negative 0.04 times 0. That's 0. Okay, so now to simplify this, I have to figure out e to the 0 power. Well, anything to the 0 power is 1. So e to the 0 power is still just 1. And so we're going to have -7 plus 27 times 1. That means -7 plus 27. Our initial temperature is 20 degrees Celsius. So that's our initial temperature when time is 0. And the next thing that we're asked for is its temperature after 15 minutes. Okay, so the temperature after 15 minutes. Okay, 15 minutes, that's a time. And remember, X is the number of minutes. Since we put it in the cooler, it's time in minutes. That means I want to know what's the temperature when X is 15. So I'm going to do a similar thing that I did before. I'm going to take X equals 15. I'm going to plug it in and I'm going to see what I get out. So T is -7 plus 27 times e to the negative 0.04 times 15. Okay, so we're going to have to put this in a calculator to get a number out. And remember, E is a very specific number here. So to put this in a calculator, we're going to have to be careful. Because of rounding error, I don't want you to round E to like 2.7. You actually have an E button on your calculator. It's above the LN button. You'll see a little like purple or blue e to the x. So if you do second and then the ln button, you'll get e to a power. And so we'll start here by doing that second ln, and we'll do e to the negative 0.04 times 15 power. And what we get out of that, I'm going to kind of do this step by step. You could plug all of this into your calculator all at once if you wanted to, but I'll do it step by step for you. To make sure that you're comfortable using your calculator here. This is round your answers to the nearest degree overall. But again, because of rounding error, I'm going to take it out to about 4 decimal places in the middle, and I'll just round at the end. So when I do e to the negative 0.04 times 15, I get this decimal. And so now order of operations, I'm now going to take that number and multiply by 27. And I get 14.8179. And then the last thing that I'm going to do is I'm going to add -7 to that. And my temperature is 7.8179. So that means overall the temperature after 15 minutes to the nearest degree, that means after 15 minutes, we are looking at 8 degrees Celsius. Again, this is initial up here, and this is after 15 minutes. Okay, I hope that helps. I'm going to make another video for you in just a minute about graphing these exponential functions to figure out what they look like. So if you would like to see that one, I will see you soon.